Good evening, we're Team Lockwatch, and we are developing a property monitoring system. My name is Jonathan Law.
My name is Anirudh Gattu. My name is Milan Mistry.
My name is Deshaun Taylor.
My name is Brandon Young.
And my name is Bene Ngoma. So the motivation for our system, existing security systems have several drawbacks. One is that they're costly. A study by Bankrate found that they average at $700, and then some of them as well have professional monitoring that would be a recurring cost, so something like $30 a month. They also have several vulnerabilities. Some monitoring systems have access to door locking mechanisms, which if they were hacked into, someone would as well as features like video feed, which something like video doorbell, which has studies have shown has already been able to be hacked into and spied on. And as well, other security monitoring systems tend to be invasive and require permanent installation, sometimes from a professional. So our solution, Lockwatch, we sought to combat this with a low-cost, portable, and user-friendly alternative that would mitigate these vulnerabilities. And this would also broaden the demographic and the amount of people that would be able to have access to security systems.
So basically, our target audiences are people who don't own their property, who are like renters, or students like us who are living in dorms, who cannot alter their living space. Those are our biggest target audience in this. Our product is very easy to install. Anyone ordering them, they can just self-install it themselves.
All right, guys, this is what our system looks like from a top level. There is the app that the user can use to see what's happening on their property. There's the web server that acts as a liaison between the user's property and the user's mobile phone. There are also these individual sensors that are entry points on the user's home, which can be used to determine if a door was accidentally left open or if a bad actor is touching a doorknob. Okay, so on to how it works. So we're using ESP32 microcontrollers to demonstrate proof of concept. We have a microcontroller hub, which receives all the status updates from the sensor on the user's property sensors. Each sensor also uses a microcontroller to be able to communicate the status updates to a central hub, which then sends this information over the internet to a Node.js web server. On this web server, processing is done to understand the data as well as store it in a database for future use. And finally, this data is then communicated to a user's Android app where they can see whether their home is secure or not and what entry points are unsecured.
So with the hardware, we built a prototype of it in the spring semester using an embed. But this semester for the Expo, we switched to using the ESP32 because it has built-in Wi-Fi and Bluetooth. So basically, you'll have each individual sensor has its own ESP that communicates with our hub over Wi-Fi. And you can have multiple sensors connected to one hub, and that all gets sent up to our database.
Essentially, for the demonstration and for the live audience, we needed to create a miniature ecosystem, and that consists of a small encapsulated box in-house with all of the sensors, and the hub is separate from that. We'll have multiple sensors enclosed within the box, some peripheral and some internal, and both of them would be able to showcase the functionality of the monitoring aspect from what we have been trying to achieve. Apart from that, all of that should be visible in terms of the status in the UI UX design from the Android application that we'll provide to the audience. Thank you.
In the process of developing our security system, we did face a few challenges that we broke down here by subsystem. Starting with the hardware, the ESP32, which we swapped to after our embed for the prototype, is difficult to implement multi-threading on, so that was something that we had to overcome. The web server faced a few security issues, mainly in setting up the reverse proxy. The app gave us some complications in maintaining the Bluetooth connection when we had to send data up to the hub. And for the demo, we had to make sure to create a suitable environment with which to properly demonstrate the capabilities of our system.
All right, so just assessing some more pitfalls and improvements that we could make on our current system. As you'll see soon in our demo, our current system has a lot of moving parts, which make it maybe more difficult for self-installation, although that is our intended use. As well as there is a latency, so a time between when some status changes, so the door is open or something like that, and when that change is updated in the app. And that was because we had to add a manual in-app delay to prevent from overloading the servers with requests. So we would want to find a way to maybe improve on that and make less time for the latency. And other feedback that we thought about for this project it would be for scaling the database for a larger user base. So currently we only have one user because it's for our demo environment, but we don't know how that would be impacted by scaling, as well as stress testing for a larger user base on our web server if there were more heavy traffic. And then another thing that we could work on is saving the sensor history and a logs page on the app so they can know when a door is open and closed throughout the day. And next we'll be showing you our demo.